My name is Stuart Halloway. I'm on the team that built Datomic and helps to continue to build Clojure. And I work at Relevance in the United States. We're based in North Carolina. And we're going to talk about the impedance mismatch. Is this a phrase that people use? Does everybody know what it is, or are most of you here just to find out what that is? Most of you got it? What is the impedance mismatch?
Beats me.
Beats me. I'll tell you what it is. The impedance mismatch is that we have these two approaches to building things, and only two. You're not allowed to think of any other ways, right? And one of the approaches is tables. It's the relational model, SQL. This is Cod and one of his 12 rules, which are numbered 0 to 12. Think about it. This is one of the 12 rules, one of the rules of Database Club. All information in the database is to be represented in only one way. Blah, blah, blah. So that's how databases work, pretty much. If you know that, you don't really need to know anything else. You can get things done. And then we have on the other side objects. Who is this man? Alan Kay. So Alan Kay tells us that OOP is about messaging and local retention and protection and hiding, blah, blah, blah. Also, it's only possible in Smalltalk and Lisp. I hadn't realized that. Maybe there are some other systems. I'm not sure this is the only characterization of OOP, but I think people would give Kay a lot of credit as one of the founders, if not the founder. And it's certainly the case that this characterization of OOP doesn't sound a lot like that. In fact, it sounds like worse than an impedance mismatch. It sounds like incommensurable, right? These things are really far apart. The other thing I want you to notice is that in order to do seriously pure, rigorous work in computer science, you have to have a mustache. Right? Mustaches are a strict requirement for people that are going to stick purely to one model. Right? Now, when you want to go from one model to multiple models, that's a hairy problem. So you need to have a big old Unix neckbeard to do that. And so you get people like Martin Fowler. And he's actually jumped in on the impedance mismatch problem. And really, the impedance mismatch, people talk about this a lot when they're talking about ORM. Right? Because that's an attempt to address the impedance mismatch. And Martin jumped into this just in the past couple of months, I guess, with a blog post on ORM hate. And there are a lot of technical arguments that he makes that are detailed and nuanced, I'm sure. And I'm going to ignore that and paint him with a broad brush and then refute him unfairly. So a big piece of his argument, and a lot of people make this argument, is, technical gobbledygook, blah, blah, blah. This is good, but it's only good for a significant fraction of the problem, not the whole problem. Right? So you can use object relational mapping, and it will get you 80% or 90% of your notion of the job done, and then you'll do the rest somewhere else, and that's way better than nothing. Right? 80% solutions are, that's how we built the world. So great stuff. He also says that NoSQL needs to be taken very seriously. Maybe that's a solution for the other things. Maybe we should be polyglot persistent, right? So we sit down to solve a problem, then we had one database, and now we're going to have 4 databases or 6 databases, and they're all going to be tuned to specific aspects of what we need to solve about databases and persistence. But he acknowledges that not all problems are technically suitable for a NoSQL database. So basically the job is, to be trite, choose the right tool for the right job, right? Which adds up to there's like 200 tools out there, and good luck and God help you, right? Now, another bearded debater about this topic of object relational mapping is this Ted Neward fellow. And he wrote a blog post back in, I thought it was 2004. The link says 2006, quite some time ago. And he makes this really overblown analogy about war that I'm not going to bother with. And he has a lot of technical points, and again, I'm going to misrepresent them and unfairly and then dismiss them. But he makes an argument at the broadest level, right, at the barroom level, where you're summarizing it in only a couple of sentences over beer. He basically argues that people use ORM because it works for a while at the beginning to deal with the easy stuff, and then you get on this slippery slope, right, of assuming that you can use it for everything, but then eventually, whammo, you hit the last mile problem, right? So again, in some ways, this is not that different from what Martin Fowler is saying, although Martin's piece is arguably an attempt to refute some of the things that Neward is saying. But basically arguing that, it's good for some things, it's not good for others. It's not going to get you all the way if your problem is non-trivial. Get over it. And broadly speaking, I would say that both of these articles, and I'm being serious now, both of these articles are essentially giving up. Right? They're saying there's not a general purpose solution. They're saying that even when you're doing a fairly general thing, that you're going to need to be polyglot, you're going to pick the right tool for the job, you're going to use some sequels and some no-sequels, and take a hybrid approach. All this to me stacks up to I give up. Right? This is a hard problem, and I don't know how to solve it. And I'm here to say today that this problem is a problem of our own making. Right? We made this problem. We invented it, and we invented it because both object orientation and the relational model as realized in RDBMS systems is hopelessly complected. Right? Multiple different things are braided together. So the word complect, to braid together. Multiple different things are braided together. And the problem with things being braided together is that in order to actually solve things, you've got to tease them back apart. Right? So when you say there's an impedance mismatch between objects and relations, you're not really saying there's an impedance mismatch. What are we saying? There are many impedance mismatches. There are many things in which OO and RDBMSs differ. And it turns out that with a fairly short list of those broken apart carefully, you end up with something that you can stir up and stack the bricks up in a different order, and this problem ceases to exist. Right? This really is a problem that we've invented for ourselves. So let's talk about some of the ways in which the OO world and the data world, as in relationals at least, differ. Relational databases have this wonderful characteristic that they process things a set at a time. Right? So you describe in a query what you want, not how to get it. The opposite of that, of course, is what? Writing imperative loops, right? Flowing around in your own language and doing this, mutable collections and object at a time processing. So, advantage, relational model. On the other hand, when you look at structure, objects have a very generic representation of structure. They're dictionaries, and you can represent anything with a dictionary. Right? Keys and values, right? Anything can be represented with a dictionary. On the other hand, in order to get some of its benefits, so we're told, using the relational model, those benefits come from having put things in rectangles and memorizing normal forms and so on. And it gives you all kinds of opportunities to do things wrong and then to get smarter over a period of years and do things righter and use the correct normal forms and so on. But there's actually all sorts of inflexibilities in using rectangles that make it not fun. So I'll say advantage objects, maybe. The access metaphor for relational databases and objects is different. Right? The metaphor for objects is navigation. I'm holding an object, what do? I should say a dirty word here that we're not allowed to say in Java, right? I follow a pointer to something else, and then I love that Java is all made of references, but you don't get a null reference exception. Right? What do you get? A null pointer exception, right? It's all just navigating around, right? The model for using Java is navigating around. What is the model for getting stuff in relational database? It's query. It's this beautiful, holy thing that has academic properties and is isomorphic to logic and blah, blah, blah. Good stuff. So, I don't know, I could see some use of both of those things. And then, and frankly, this is the biggest one, relational databases are over there, if you're a programmer, in every sense of the word. They are typically across the wire from you. They are sometimes across a political divide from you, across an organizational divide. They are typically using tools that you don't like and languages that you don't like. How many people prefer some flavor of SQL as their primary language for agile development? Finally, I found a question that no hands would be raised for. Right? Nobody wants to use those tools, and the over-there-ness causes, all kinds of problems. So let's drill into some of the weaknesses of some of these individual places. So, and I made this point, those of you who were in the previous talk. If I want to, one of the things I want about a software system is if I can say something, and that my statement has, logically is kind of atomic, it's one thing. I want to be able to go do one thing in my system to make that thing happen. And when I don't do that, if I have to repeat myself, what principle am I violating? We have an acronym for this. I'm not dry. Right? I'm not dry if I do that. Well, think about what you have to say people can belong to multiple clubs. I can say it in English. People can belong to multiple clubs. And we can argue about how much information is in that sentence, but it's less information than I have to say over here, right? No matter how you slice it, right? You might say it's 3 pieces of information, but you're not going to say it's a join table and a person table and a club table, the ID key, the person key. And all of this is stuff that we call structural navigation. You're not navigating your own domain model. You're navigating the structure that was imposed on your domain model in order to play along in the system. Does anybody find great benefit from doing this? Well, there must be some benefit or we would do it. Why do we do it? It's not because we like this. It's because we like what? So we like the queries that we get out of this. We like being able to pay the Oracle license. There's some benefit that we get out of doing this. We want to have some power somewhere else, and so we're willing to put up with this. The over there problem, as I said, is the biggest one, and it gets you again and again and in different ways. So this is a quote about, this is another person who is actually responding to this series of blog posts and made an observation that, yeah, you can fix this particular problem with query by decorating them to tell the persistence layer to go do other things while you're doing this thing. And so there's this notion when you're talking to persistence that's over there that you're going to ask it to do a whole bundle of things in one operation. And when I was first learning that, I was told this lie, right? That the primary reason for bundling these things together is for performance, right? That I want to bundle these together to avoid round trips and the n+1 problem and those kinds of things. But the real reason that we want to bundle these operations together is that the data lives over there. And so if I make 2 separate trips over there, I now have a really big problem, right? What happens if somebody else came over there while I was in between those 2 trips? Right? And then we could do some really crazy stuff like, well, you should really go back within a millisecond. That'll probably be okay, right? I love timing arguments. Right? This will work. This software system will work if you follow these carefully dictated. And of course, it doesn't even work, right? A millisecond is no guarantee, right? So we get ourselves into all kinds of problems with that aspect. And so then we start doing things in query that are unnatural acts, right? Telling query extra information to bring back is like query bestiality. It's totally awful, inappropriate, should not be done. On the flip side, here's another statement of essentially the same thing. And you can read this as Ruby on Rails sucks because it encourages you to decompose things. Now, as software developers, we decompose things for all kinds of reasons, right? And sometimes we have things delivered to us already decomposed, right? If my job is to assemble a system, and everybody on the front row here is going to help me build it, and we divide the work up 5 ways, it's decomposed because we divided the work up. Even if it didn't have to be decomposed, right, we're going to build systems. We're going to end up having to have things decomposed. Sometimes we're going to decompose from a good design perspective. Sometimes it's decomposed because that's just what we have. And why is decomposing things bad? It's not. Except for this cruel and unnatural act of having to go over there. Right? If I have to go over there, everything has to be recomposed and done in one trip. And so this issue just creates miles and miles of work for some unfortunate soul who wants to build or use an object relational mapping framework. So this is part of the impedance mismatch. It turns out, though, that my earlier slide listing characteristics of these systems was incomplete. That's actually by definition true. I'm not going to completely say anything today. But it was incomplete in interesting ways that I'm going to correct even in the time that we have here. There's a couple of other things about these systems, and these are things where they actually kind of have more in common. Neither object-oriented systems as we usually use them today, nor relational systems as we usually use them today, are programmable. And it's really disgusting that we program with programs that aren't programmable. And I'll flesh that out in a moment. They also both have a model of perception that is typically coordinated. And what that means is, and this comes up again and again in different ways, but what that essentially means is that we have to coordinate activity in order to observe something happening, to perceive something happening in the system. It requires me to say, I want to see you. And then you say, okay, you can see me now. As opposed to, I just look at you, light bounces off of you. How many people were in Rich's keynote yesterday? Right, this is the place problem. Right, this is the problem of talking to places. Because our both object orientation and databases are a metaphor for place, then I can't actually know a fact. I can only know a place. Which means that if I want to think about something, I have to go to the place and get it. And I have to go to the place again. And if I want to know 6 things are related to each other at a point in time, what do I have to do? I have to go to the place and pull those things together. In the database, this may have implications like having to do a transaction to read. And on the OO side, this may have implications like what? It's actually arguably even worse on the OO side, right? Databases actually have a metaphor for dealing with this, which is composable, which is transactions. What's the metaphor on the object side?
State.
It's state, and how do we protect it? How do we coordinate reads in the OO world? So first off, let me just assert that if you don't do anything about this, that reads don't work. So if you're not doing something about this, or if you're not participating in some sort of framework that's doing something for you, your programs essentially don't work. So we must do something. What is it that we do? We lock. Well, there are other things we could do, but we lock. How many people are really good at that? Rich Hickey raised his hand. Look at that. He is pretty good. Rich Hickey has written a lot of locks so that hopefully others of us won't have to. There's a very short list of people that are really good at writing code with locks. And locks don't compose. I can't take 2 arbitrary pieces of code that each do locking and then combine them together without knowing implementation details. Which means that the entire notion of reuse in OO is broken. Fundamentally broken. Right? I can't take, and the only way it can be repaired is through heroic effort. Right? So, which I will acknowledge people make heroic efforts and can build things. People can build software in all kinds of ways and overcome these limitations, but it's a really terrible limitation. And it's really shared. This perception issue is shared with object-oriented systems and relational databases. Finally, the action metaphor in relational databases is transactions. In our case, we don't care about what the action metaphor is on the OO side because we're trying to make action happen in the database. So there may be action metaphors in the OO world, but I don't even care what they are. I really care about how to work with the transaction system. So one thing that will happen on the OO side is that object relational mapping may provide tools to help you use transactions. And typically, helping you use transactions is a way of saying, I think you're too stupid to use transactions correctly, so we're going to give you something where you call methods on objects and then magically transactions happen somehow in a way that is correct for your system. Which is another thing that's, it may be a hopeless job to begin with, but it's very difficult at best. Now, I want to come back to the programmability because probably at least a few people said, what the heck does he mean when he says that my programming language isn't programmable and my database isn't either? There's a cartoon about the programmability of SQL. Right? If I want to make SQL programs, what are the atoms that I use? We all know what this is. What are the atoms that I use to make SQL programs? Strings. Right? Has everybody met little Johnny Drop Tables before? Right? Little Johnny Drop Tables, whose name is Robert, quote, paren, semicolon, drop table students, semicolon, dash, dash. I really want to name my kid this. Right? And this is showing up the fact that SQL is not programmable unless you consider string concatenation programmability. And that's pretty darn primitive. Right? And yes, we can. And this is what we have to do, right? What are JDBC drivers at the end of the day? Right? Things that concatenate strings together for you and try to make this not your problem, but still a problem. How about Java? So Java has one big advantage over the relational model in terms of programmability. And that advantage is that there actually is a binary specification for data. Right? Java programs could be viewed as binary data, the class files. And so you could, in fact, write tools that enable programmability of Java at that level. This is one such tool. This is a third-party open source, I guess, tool called JavaSys. There are others. What's the one that's in Clojure that emits bytecode? ASM. So there are a bunch of different tools out there like this. But I would argue that the fact that they're not part of the language makes them not first class. And the fact that when you go to use them, you don't get to manipulate the same tools that you would manipulate when you were writing a program means that Java is not very programmable either. Right? So this is a cottage industry that has sprung up to deal with the issue. But the fact of the matter is that they can only deal with the issue at the level of class files, not at the level of Java programs, because Java programs don't have a spec or documented information model. Right? So there is no model that we can use to program our programs on the Java side or the SQL side. Now, I'm not saying that nobody ever gets any work done. Obviously, these things are overcome via heroic effort. I'm saying that the effort is a poor use of time. Coordinating perception is insane. I do not slow down because you're watching me. right? But most programs slow down as read volume goes up, right? Just in-memory read. I'm not talking about database read, right? Most programs slow down as read volume goes up because you have to lock to read, or you have to do something to coordinate read, because reads happen not of values but to places, right? And so somebody else can go and change the place. So until you program with values, you have to coordinate perception. In the real world, records are immutable, right? I got married in 1998. If my marital status changes, that record in the courthouse, they don't go burn that. Right? That's not how I get a divorce. Although maybe that would be a dramatic way to do it, right? But, but that's not how it works, right? Records are immutable. And reality is cumulative. The past did not go away because the future happened. This past is still there. We all remember it. We can think about it. So coordinating perception is a really bad idea. Now, I've really touched in the last couple of slides on programmability and perception and trashed both sides of the equation on both of those scores. I will say, the only nice thing I'll say either about databases or as they typically exist today, or about Java or other object-oriented languages, the only nice thing I will say is about transactions. Transactions are awesome. Transactions are composable. We can understand how to reason about them. They're part of what give databases their greatness. So I've got no qualm with transactions. Now, that's the world that we've made for ourselves, and we should all feel embarrassed. Here's the world that I want to imagine. Imagine a world where processing can be set-oriented or tuple or entity-oriented, right? Where you don't have to make that choice. If it's useful to you to process things a set at a time, you can. Object at a time, you can. Imagine a world where you don't have to make a choice about structure. You can use dictionaries, you can use rectangles, you can use columns, you can use documents. It just doesn't matter. Imagine a world where your access model includes both query and navigation. And you can mix them freely. I can do a query, and then I can say dot left foot, dot left toe, and, navigate around, and then I can switch back to query. I don't have to worry about location. My data is available everywhere. It's programmable, so there's the ability to write programs that write programs without heroic effort, without string concatenation or Java bytecode manipulation. And perception does not require coordination. Again, back to Rich's talk yesterday, values are there. You can look at them. Once you've looked at them, nobody else is going to sneak in and do anything to them. And you can use transactions if you want to, but frankly, there are other coordination mechanisms. You could choose one of them as well. This is the world we should live in. And the only way we can get to this world is by breaking apart both sides of the equation and doing something different. We cannot accept the relational model in its entire, or I shouldn't say the relational databases as they exist in their entirety. They do too many things, some that we want, some that we don't. We need to break that apart. We cannot accept our object-oriented languages in their entirety. They do too many things. We need to break that apart. And then we can get there. And of these various categories, there's one that jumps out that really, if you don't figure this one out, you'll fail in this exercise, which is why people haven't solved this more frequently prior to the last couple of years. The reason that people don't solve this problem, which one of these rows, getting it right, enables the others? Programming with values. Right? This is why programming the value of values got to be a keynote. Right? This is really important. If you take nothing else away from the conference, take this. Because all of my efforts to make sense of the rest of this will fall down if I don't start with that one. If I start with this one, all of a sudden the choices become easier everywhere else on the matrix. Right? And this is how design works. Right? You get all of the different pieces in play. And I'm not saying this is all. This is an hour talk. We could have a longer list. We could get more pieces in play. But you get all the pieces in play, and you start solving for it, and you find the things that are really key, and then they start to constrain and guide the rest of it. And then eventually you get to the point where it's easy, and you're just ticking off boxes, and you're like, boom, out pops the design. So let's do it. Here we have a blank slate. I said I was going to start with values. I'm going to cheat from an ordering perspective and start with programmability. Everything is going to be made of data. One way to do it, the way I like to do it, is that programming in a Lisp, in an immutable Lisp with values. Some people might say Clojure, for example. But this is not, I want to emphasize that this is a talk about ideas, and I'm going to show you one path through here. There are other paths through here. And there's a point at which you can branch and make other choices than the ones I'm making. You're not allowed to branch yet. You need to be programmable. You don't have to be a Lisp. If you can find some other way to do it, that's great. Secondly, data is immutable, which gives us values for perception, but also solves the location problem, right? Because when things are values, it doesn't matter where they are, right? 42 is 42, whether it's on your machine or my machine. Likewise, my address is my address, at least at a point in time, whether it's on your machine or my machine or 1,000 machines, right? Values can go anywhere. If everything was modeled with objects, and we started delivering all objects over HTTP, let's say all objects have their own HTTP endpoint, what would the cache control header for objects be? What kind of caching can you do? None, right? What would the cache control header be for a system where we expose everything and they're all values? What would the cache control always be? Infinite, right? You can hold on to this. This is the point, right? This aspect really is, values are location transparent, right? There's all kinds of fantasies and foibles trying to get location transparency, but values are location transparent. These choices are fundamental. The choices I'm going to make next, you could make different choices, and I would encourage you to try. So, here's a choice that's not going to give us anything on the grid yet. The fundamental unit of data is the datum. So a datum is entity, attribute, value, time. I'll give an example. Stu likes pizza. I'm tired of John liking pizza because I don't really know John's opinion, so I'm changing my example up for those who were here earlier. Stu likes pizza as of right now. The time thing is what makes it a fact. Right? If I just said Stu likes pizza, then tomorrow when I don't like pizza, if I go back and try to change that fact, I'm now back to place-oriented programming. Right? I can't work that way. I have to have a value that says, as of now, Stu likes pizza. As of tomorrow, I may become lactose intolerant, discontinue to like pizza, whatever. And anything smaller than a datum is not really capable of being a fact, right? If I said Stu pizza, no fact there, right? You play the game yourself, right? There's all these combinations. If you take out any one of these things, you don't end up with a fact. If I say Stu likes, there's no fact there. We don't know what I like, right? Stu likes pizza as of some point in time. Now, the cool thing about this as the bottom is that datums can be mechanically turned into a dictionary. And I talked earlier, I picked at those ORM things as 80% solutions, right? There is a 100% brainless one-line program that you can write that will convert a list of datums into a dictionary, right? All you do is take all of the entities and drop them out. All of the attributes become the keys. All the values become the values, and then keep track of time somewhere. Right? But you can also mechanically translate datums into rectangles. So if you want to have that rectangular feeling report, you can translate datums mechanically into rectangles. You can translate them into columns. So if you're of an analytical bent and you want to do OLAP type work with your data, you can feel like they're columnar if you sort them by what? How would I sort entity, attribute, value, time to make it feel like a column store? Sort by attribute and then value, right? Attribute value would then feel like a column store. If I sort them by entity, it feels like a row-oriented store except better. Right? Because one of the things, and this is you get back to the rectangle problem, what goes wrong with rectangles? Is a rectangle an entire entity? Does a rectangle represent everything about you if there's a row in a database for you? No, because we're going to model with normal form, which means there are going to be some facts about you of which there's a multiplicity, which means there is no real good row that is you. But if you represent things with datums, and you have a sort of datums by entity, then everything about you is where? And actually, you still got an F through values. So that's not totally true. But you've got a better start. Finally, and this somebody observed in the previous talk, modeling things as entity, attribute, value, time can trivially be transformed into a graph by just recursing, right? I like Rich. Rich is another entity in the system, right? Rich likes Steph. Steph likes Joey. On and on and on, right? That recursive query starts to feel like those hip graph queries that people like to write. And so this data already feels almost graph-like when represented in this way. And of course, it's easy to translate datums into something that feels like an entity, which usually we don't actually get. Right? Usually the unit of representation in our systems doesn't ever actually map to entity. Right? Rows are too small and also too big. Right? When can a row be too big? It could be a sparse data set. And so rows have all these unused columns. So they're too small and too big. What data structure have I not talked about here? Sets. So actually, I have sets over here, set of datums. So I kind of have sets. What other data structure is hot in the database world right now? I've just listed most of them there under structure. Is there anything missing? Yeah. Objects. Well, that's true. That's fair. They're on the other side of our equation.
Okay.
But yeah, that's fair. Objects missing. Anything else? Document. Oh my God. Q rant. Stop using documents. What the hell? Documents are where information goes to die. Right? Document is a baked thing. It's way more baked than a row. It's the biggest form of schema lock-in you could possibly pick. There could be nothing worse than a document if you want information that you want to use in any other way than the way in which it was put in. Documents are great if you know that you want to use information in exactly one way and that you can chunk it in that way. Then documents rock. For everything else, they're the worst form of structural lock-in. Think about all the things that you ran away from tables for. Right? Oh my God, I have to navigate from here to here in the table. Right? When you're in a document, what are you now doing? You're now navigating object style through a document, but you no longer have mathematically founded language like SQL to help you do it. Right? You have all the problems you had with rectangles and worse. So stop abusing documents. Now, the flip side is a document is the beautiful end result of a query. Right? A document's not a great unit of storage, but it is a great answer to a question. Right? When somebody comes in and pounds their fist on the table and says, I want that report on my desk in 5 minutes, the report that they're picturing is probably a document. Right? It's not rows or columns or datums or any of those things. So I think the right way to conceive of a document is typically going to be as the answer to a question. Right? But not the place you go to look up answers to a question. Because the lookup capabilities are simply not there. For access, I want to have the power of the relational model. And basically there are two ways to get that. I can have something that's the relational algebra, or I can have something that's a logic that's equivalent. So one choice you could make here is something like data log. Right? And this gives you the ability to use pattern matching style to formulate your queries. And it has all the same expressive power as the relational algebra, including recursion, which relational algebra typically does not, although relational databases typically do. Data log is also set at a time. So we get that wonderful, I'm not navigating through lists of things characteristic. We get that, I want to get back the set of answers. The flip side, though, is if you want to, you can use something that's closer to prolog than data log, and that's something that's tuple at a time. So if you have a problem, I think the general rule is you're going to want something that's set at a time for most problems. But if you have something that ends up being tuple at a time, then you could do that as well. Finally, and this is a really beautiful thing, when we write queries today, and this is true if you're doing relational databases, it's true with other kinds of databases, it's true regardless of whether you're doing any ORM. When you write a query, you tend to say, go find the entities I care about and grab all the attributes of those entities that I need to answer my question. And why do we do that all in one go? I mean, we just talked about this a second ago, right? I have to do that all in one go, because what happens if I go back a minute from now? Maybe the world has changed. Right? I want to do that all in one go. And so we're all taught to bundle up all this work and try to get it done in a query. If you program with values, then you can have a query find the entities, and then you can lazily collect the attributes whenever you want. Right? And the interface for that looks a lot like HashMap. It's actually a lot simpler than that. It's just get of an attribute. And that thing is actually better than a map. Right? It's a multi-map in the sense of you could have a multi-valued attribute. So you can say, I go and find all the people in my query, but I don't specify which attributes that I want to use. In fact, I hand that off to the guy who's writing the JSP page, and he picks the attributes he wants. What would you do on a database project that you were working on if you saw somebody interacting directly with the data in their JSP page? Oh my God! What? And I've seen projects where people did this, right? Where you go back and the connection is actually still open on the JSP page and you go and do stuff. That's only an anti-pattern because the data's over there. I'm not saying run out and do a ton of work in JSP pages. There may be other reasons not to do that. But you could, whenever you wanted to, pick up attributes of your objects, and because they're values, you don't have to worry about the world having changed out from under you while you were thinking about it. Notice that, by the way, I'm also starting to put exclamation points on places where some features have enabled others. So each time something is enabling something else, it's getting a little bonus kick there. Now, here's the choice that there are certainly other options. I really like transactions. Transactions, I said before, are awesome. The ACID properties are awesome. I think that 91.4% of people who have walked away from transactions could have had the characteristics they needed in the system and had transactions too. Right? 91.4%. Now, 72% of statistics are made up on the spot. But that being said, 91.4% of people that have walked away from transactions unnecessarily. If you have a system that's based on values, then you can offload all of the read work to some machine that's not doing transactions at all. Why would the transaction machine ever serve reads for anybody? Right? It's just a waste of its capacity because it's that special guy that does transactions. Once you've taken all the read load off your system, how many people suspect that your reads represent more than half of your load? Show of hands. Wow, less than half of the people think that reads represent more than half the load. Very strange distribution of work. How many people think that reads represent a non-trivial fraction of your load? All the people whose hands up were 4 still have to be up. This is just like an exercise in Venn diagrams. If you can take the read load off the box that does writes, then the write box doesn't have to do as much. At which point, it makes a lot of sense to say, you know what? We're just going to serialize everything. Remember those old isolation levels and read committed and all that stuff? And isolation level 3 was like this nirvana that killed performance. Serializable. Heck, we're going to go to isolation level infinity. Serialized. Just serialize everything. And there has been research that shows that even on traditional databases, serializing everything is a win. Right? This is often a win. This is the research behind, for example, Volt. Right? Combine that with not serving reads from the database, and you get yourself in a really nice place. Now, it is fair to say that in ORM, we had helpers that helped us compose transactions, that helped us make transactions. And that is still true in this world, but these helpers are so different that it's really dangerous to even compare them. Transaction functions are pure functions. They take data and they make data. They are shipped over to a machine that can do transactions, and in that machine they take a piece of data like increment John's account balance. Then they can look in the database, figure out what John's account balance currently is, so that they do a correct ACID update. Because we can't just send an assertion to a database that says John's balance is now 110. We have that same it's over there problem. And now the over there problem is real, because coordination really does have to happen somewhere. Right? So I kept saying that all that over there stuff is a big problem for if you presume that for reads when you shouldn't. Now you really do have to presume it. Right? Coordination does have to happen somewhere. And typically there will be some parties in the system who are not part of coordination. So when those parties want to institute change, they have to send something somewhere else. And when they want that change to be atomic, they need to be able to send behavior to that other place, right? Not just state, because they need to say, look at this and then do that with it. And that's the role that transaction functions serve. Now, having done this, and having these characteristics, you get a bunch of things for free that fall out of this. One thing for free you get is a time model. Given any database, you can say something like database as of last month. Because we have values, because everything is time-stamped, it's trivial to now say, if I have a database that represents now, just ignore the stuff that's stamped within the last 2 weeks as part of your query. And this is a lot better than putting time into your query. How many people have ever worked on a system where you had this great set of queries that represent now, and then someone came back and said, I want to run a query that tells me how things were? Right? And now, you write that query that tells you how things were. Do you use the how things were query and pass in today's date to get the now answer? Typically, no, because the performance of that time navigating query is not very good. Right? So you end up writing two queries. You end up writing a whole family of queries for now and a whole different family of queries for then. And this is in that like 20% that ORM doesn't do, by the way. Now you talk about, oh, it solves 80% of your problem until your system actually runs over time and you start needing to do additional things. Another thing that falls out for free from this approach is that you can scale read and query horizontally. Read and query depend on values. Where do values have to live in this approach? What location do values have to live in? It's a trick question. Where do values have to live? They can be anywhere. If they can be anywhere, then I can go into EC2 and I can say, configure my query boxes. When they see this happen, spawn 4 more. And if you see that happen, subtract some. And I can have not just scalability, but elastic scalability of read and query. Because all that stuff can happen anywhere, and it can happen on stupid boxes. Right? These boxes don't need to do anything fancy to spin up. They don't have to be synchronized. Synchronized, dirty word, you can imagine. Right? They don't have to be synchronized. There's no slave database that replicates the master database or any of that complexity. It's just the values are available. And of course, once we're going to do this with the values, we're not going to put the values on any one box. Right? Spinning your own disk on your own box is so 2010. Right? You want to put those values in a storage service. You want to have them, and you want to have that storage service do things like spin disks for you, and you want it to be able to say things like, I really want my values to be on 5 different disks on 2 continents. Knock yourself out. Right? Pick a storage system that has that capability, and then strap this on top of that storage system, party on. Another slightly less intuitive consequence of this is that you can do what-if queries. Right? Because everything is made of data, and because you have the whole value of database anywhere you want it, you can say database.with some new data that hasn't actually been put in the database. And whatever machine you're on can do the same work that would have been done in a transaction, but only on that local guy. And now you can start running queries and say, oh, if I made this change, what would happen in the system? And of course, you can do multi-source queries. Right? The minute that the database is available as a value anywhere, there's no point in making it ambient in the query system. Right? SQL, the database is ambient. There's no variable that says, I am the database. But you might as well make that a parameter here and say, you know what? I can source my queries from more than one database. And those databases can have their values stored in more than one different storage. I don't care. And I can join across those. Now, the great thing about this talk is that it comes with a home game. You can play the home game. And the way the home game works is like this. Step 1 is simplify, which means try to break apart things that are combined, complected unnecessarily. So I've got an extra row down there at the bottom for when you simplify and find something that I didn't enumerate today. And you might be able to find dozens. Right? Take one of these ideas and break it apart and make a new row for half of it. Or take something that hasn't even been covered here and go, this is another important aspect that Halloway totally missed, and add those rows. Then, the only rule that I'll put on you is program with values. And I keep sneaking in, location falls out, right? Location anywhere falls out of programming with values. Those are the key enablers. You may be able to find other things, right? I think I just made like a card for like 30 Y Combinator startups, right? Go and fill in these blanks different ways and announce victory. I'd like to leave a significant amount of time for questions, but I do want to end first with a thought from the bearded man again, Martin Fowler. And one of the things that he says in his article about ORM hate, which is really about the impedance mismatch and what people do about it, one of the things that he says is, if you're going to dump on what we're doing, you have to state an alternative, right? This is the, I guess it's like the opposite of the Hacker News approach to the world, where you just show up and dump on stuff. Right? This is, you can dump on stuff if you want to, but you have to state an alternative. And so I'd like to conclude by saying that I think that what I've done in the last 40 minutes is stated an alternative. I think I've stated an alternative that is fairly comprehensive. Right? It doesn't solve one aspect of the problem or another aspect of the problem. It really makes the impedance mismatch go away. Right? It's gone. You can actually program with your data as data in your system. And let me just mention, on a slight side tangent, that I haven't really said anything about object orientation at all. And since this is a rant, I'll just go ahead and say that it's stupid and you shouldn't use classes and OO and all that stuff. But nothing about what I've said today actually precludes any of that. Right? If you want to knock yourself out once the data is in your process, putting it in objects, that's fine. Whatever. You can do that. You're not, and with this architecture, you're not hurting anybody but arguably yourself, if you believe my perspective on that. Right? But you can knock yourself out, do whatever you want to do in your own process, and that's great. But the other thing I want to say about Martin's observation here, I think that what I've laid out here is a fairly comprehensive answer to the question. And so I will say, gauntlet thrown back, alternative stated. But I'll also say that this is a hard problem that people have thought about for a long time. I'm sure that the ideas that I've presented here are imperfect in themselves and imperfectly explained. And so I would encourage you to think about them, to send me nasty emails with things that I didn't do right, and try to find flaws in this approach. Because if I'm right, as an industry, we're really far from right. This is a very different view. Although, it's interesting. I mean, how different is it really? There's not a single concept that I've talked about today that we don't already employ. They're just stacked up a different way. Right? And that's really what simplification allows you to do. Take a thorny problem, break it into pieces, stack those pieces a different way, and get a really different outcome. You can find me on Twitter to mock me at the listed address. I want to say thank you very much for allowing me to be your afternoon iconoclast, and now I'll open it up to questions. So the question is, what about coordinated time? So I will say first off that the box where I said transactions are used for coordination is definitely a box where you should feel free to experiment. Right? So there are other coordination strategies that are appropriate for other kinds of problems. So it's not like that's the only way you could do it. That being said, the facts in the database are time-stamped with what somebody in a previous talk called technical time. Right? It's ascending order as the database sees it. Those things are then tied to the real-world date as known by the database. Right? Those are now separable problems which you can deal with individually. So, for example, you could say, well, gosh, what if my database clock is set wrong? Well, if your database clock is set wrong, you got a problem, right? But you can. That's not a problem that's permeating through the system. You could also say that there are timestamps that have nothing to do with when the database knew it. So one of the subtleties about starting to think about time is that it's not just the case that when the database says Stuart Halloway likes pizza yesterday, what that really is saying is that the database found out that I liked pizza yesterday. You might want to say that we actually know that I liked pizza from a long time ago. And you can store that as a fact. And transactions, or at least in the concrete implementation of this that we've worked on, which is Clojure and Datomic, transactions are themselves reified objects. So that's where the time is stored. So instead of having to store the time on every single tiny fact in the system, which would really be inefficient, you can store the time on the transaction. You can hang your own information on the transaction as well, which is actually a wonderful thing for any system where you care about auditability. Right? So you can say on every transaction, I'm going to hang who said that, or which web machine it came from, or whatever facts about the events as they came into your system are that you care about. So it's definitely an issue. And this is so the question was, we don't have infinite money to capture infinite time. It's definitely an issue. I'll offer a couple of anecdotes first, by way of just being an iconoclast and poking you, and then I'll give a more serious answer. The anecdote is, people said the same thing about Git. We cannot possibly move from Subversion to Git because we cannot store infinite code. How many people did not move to Git because we can't store infinite code? And it was really surprising. I remember that when Ruby on Rails switched to Git, how much bigger is the Ruby on Rails Git repo with all of history than just a download of Ruby on Rails? Does anybody know? The last time I checked, it's 2x. Right? It doesn't have to be a big multiplier to remember all of history. The other piece is that in the implementation, which I haven't talked about here, but the implementation behind these ideas, which you saw some of in earlier talks, right? The data structure is a tree, and so updates to that tree invalidate old nodes. If that were all done in memory, garbage collection would take care of it. You have the same, actually simpler garbage collection techniques to apply, because we can just delete those old values. And so we don't have to keep, that would get big, right? If we had to keep the old node structure, that would get large. But keeping history itself does not necessarily get large. The other thing that I would point out, and this is really important, is that it's indicative of the fact that this approach changes the whole debate, that we can now even have an argument about this problem. Because most systems are not able to make any distinction between I forgot because there was a bug, or I forgot because somebody deleted it because it's not true anymore, or I forgot because somebody deleted it because it was a mistake, or you can't even start to have that conversation about making those separate cases until you're actually programming with values. So I do think that there's follow-on work that can be done there. And so certainly you could have a system like this where you said, I really don't care about that stuff, let it fall off. Right? There's nothing, the fact that you're able to keep values doesn't mean that you have to keep everything. Right? You could still choose based on some policy to say, I'm going to let this stuff go. But in general, a lot of systems are going to find that they're going to be happy with that. Double the disk space to have all of history and reduce development time, and the kinds of things that this enables, the ability to say, I want to do OLTP and lightweight OLAP from the same system, right? The development cost, not to mention the fact that if you have to do a disk for your OLTP and then you have to put it in a different format for OLAP, there's double, if not more. So I think they have a lot of choices there. Yes?
One of the problems about Git is that it has a hard time forgetting things when you want it to.
Yes, and that's definitely something that has to be sorted out in these issues.
Yeah, I think what you propose here has the same problem. What do you do if you have a legal requirement that you can't keep transactions in your database for more than 3 years?
So what our implementation does right now, we're still thinking about what to do about that, but there are definitely approaches you could take. Right? So one thing you could do is have a bit code for expunge and go through and mark things that you want gone, and then have some background thing that just walks through the tree and rebuilds the tree. Right? So conceptually, there are approaches to doing this. We have not picked an approach yet because I think it's an interesting and challenging problem, and I think that both people and the law, in a lot of cases, have not carefully thought through the issues. So, for example, if I'm told that as a legal requirement, I got some of your private information, I'm not allowed to know it anymore, and so I have to get rid of it. Have I complied with the law if I get rid of it in the indexes of the database? Do I have to go to Iron Mountain and pull the tape out and go to the spot on the tape where it was recorded as a log entry and carve out that little piece of tape? I think this is an interesting and complicated problem. I don't think having the ability to remember puts you in a bad position, though. I think having the ability to remember is a good starting place. And our existing systems don't have that ability. Yes?
So I have a question about kind of transactions and about this idea of programmable programs. And it may just be that I don't quite understand the thing. But let's say that I can. I've got some code that compares two foos, and so like my application compares foos by doing this at this moment in time, and then I create a transaction, and to serialize that transaction, it's going to happen at some point in the future. And then there's a new version of comparison. I decide that from this moment onwards, my application compares foos by doing a different thing. When that transaction runs, does it have the comparison that was true at the time it was created, the one that's true at the time it runs, or is that a problem that needs to be solved by the client that's using the code?
In general, it has access to both, and the typical idiom. I mean, without drilling into the specifics of the problem, there might be more than one choice here, but the general top-level approach is that you use a transaction function. Inside the transaction, you have the in-transaction value of things, which is as of that moment in time. And so you have that in order to make decisions.
Store the code as part of that transaction.
Yes, and you can store code in the database, right? Code can just be checked into the database, and it has all the same versioning characteristics. So you can do interesting things where, this is a really big problem in some systems where people say, I need to run a report against the data as of 2 years ago using the code as of 2 years ago. And I'm not saying, run out and stop using all programming techniques and check every function into the database, but you could definitely do some of that, right, where you put functions in the database and then use them, and then they are time coordinated with the data that they work with. Yes?
You chose transactions, you like them, but often also you would like availability. And typically then you have to distribute things, and then transactions become really hard.
Yes. And I believe that many of the aspects of the system, but not all, could be had in a system that was built around a different coordination principle. Right? The values, right? You have to have, there'd be some stuff to be worked out, but I think you could definitely do that. It's not my interest right now because it's taking about 19 hours a day to work on this. So I try to use the other 5 hours to sleep and drink. But I think that again, simplify, right? Many of these building blocks could be assembled in a different system that had different characteristics. Also, when databases are values, there's less incentive to put everything in one database because you can get to more than one database and bring them together with you. I have to admit that I'm still trying to sort the implications of that myself, so I'll get back to you in a couple of years. But it's definitely the case that you could build something that was built out of a lot of small databases, and maybe those databases you don't even care which one the fact gets into, right? As long as depending on the characteristics of your system, right? So there is one story for building something that is bigger that works like that. All right, it is. Oh, we still have minutes. Come on. Somebody ask a dumb question so I can make fun of you. Yes?
The time value of your datums, is that representing the time of the value? Like, I've booked a trade on this date. That's a trade date. Or is it the time of the edit to the value?
It's linear relative time by the transactor. So it's, this event happened at 1, this event happened at 2. However, that transaction, that I'm transaction 2, has an attribute on it, which is wall clock time, which is when it happened in the system. Right? But you may still have other times that you care about. You can also store them as attributes on the transaction. Right? So you can add your own attributes to the transaction as part of an update. And then, I should never say update. What word are we going to use for that? As part of an add to the system, right? You could put other attributes. But if you just need the wall clock time on that machine, if that's actually the definitive time for a financial system, then it could just be that. If that's not it, if it's passed in as a parameter, then you can add that to the transaction.
Is this not what was called temporal databases a few years ago?
So
every row had the timestamp.
So every row having a time. First off, that's different because having the transaction have the timestamp gives you an opportunity to have the overhead of storing the time be a lot lower. Right? If every row has a timestamp, what does that even mean? Right? That's actually kind of fundamentally problematic because I don't actually know when any of the columns changed. Right? The only way you could actually simulate these semantics in a relational database is have every column have its own date. Right? So first name date, last name date. Right? Because or reify transactions into your system somehow.
Not really true. If you have 2 timestamps, valid from and valid to, you have all the versions of the record, so to say. So you need 2 timestamps in every row.
So if you save the old ones as well.
This record was valid from this point in time until this point in time.
And you keep that old record.
And these are non-overlapping.
Yes, if you keep that record, then you have a way to do that. That's right.
Then you have a fully temporal. Then you can basically say, how did the report look at that point in time?
I wish you good luck.
Row per edit.
What?
You have the overhead of storing a row per edit.
Yes.
Yeah, that's huge.
You have a value per edit.
That's much smaller than a row.
So, all right. Thank you very much. My name is Stuart Halloway. I'll be out in the hall so you can throw things at me. Thank you.